And I think there we go.
Excellent, excellent. Let me introduce, last but certainly not least, but in San Francisco, I believe. So John O'Donnell, CEO of Rondo. Hello, John. Thank you for joining us.
Hello, thank you. It's wonderful to be in such august company and talking about this subject. I'm really grateful that you've put this together. People have said that the industrial sector is the hard to decarbonize sector. And the people on this call and what's going on with renewable electricity is moving that to the rear view mirror. Right? We are moving into an era where we can have zero carbon energy at a lower cost than fuel now in a number of places in the world, including in the Middle East, at costs that 10 years ago were just unimaginable. I spent 15 years of my career working on concentrating solar technologies for heat. And solar electricity and wind electricity, for that matter, have fallen below the cost of burning fuel, so that regardless of the technology, we are in an era where if we can deliver continuous heat from intermittent electricity, we can repower industrial processes. And I'm delighted at the breadth of folks that you've brought to this discussion. I think Blaine is going to speak next, and his report is right in the middle of this slide. I would point you at some of the others, and I think you mentioned you thought it's a 1.6 trillion market. Tesla thinks it's a 3 trillion market, and that the world is going to have twice as much heat battery capacity installed as electrochemical batteries serving the grid of all kinds. Another study that was published not too long ago looked at how energy is used in industry. And many of the technologies that have been discussed today can address most of that. The little check boxes here are industries in which Rondo is already in contract and or building projects. We are a team today of about 140 people, leaders from heavy industry, from concentrating solar, from cement, from hydrogen. Part of our team built the world's largest solar thermal systems serving industry that still today delivers half of all the world's solar industrial heat. The team now includes across supply chain and grid and intellectual property and finance. We're across 7 countries and working to deliver at scale to meet the needs of some of the most important industries, right? Fuels, plastics, AI, critical minerals, building materials, and working with leaders, Breakthrough Energy and Energy Impact Partners, SCG and Titan were our Series A investors who saw the potential years ago for heat batteries to make an enormous difference. And among all the folks who are talking to you, I'm kind of proud to be the most boring. I mean, there is one of the things that is critical for deployment is industrialization. Innovation is critical. New materials in some cases are critical. But in order to deploy, it's got to be industrialized. And look, one of the matters is if we're going to deliver heat batteries and put them in factories, they have to meet much higher safety standards than electrochemical batteries. One of my favorite standards for electrochemical batteries is a UL standard that says, when your lithium-ion battery catches fire, it won't set the next one the one next to it on fire. That's not an adequate standard for heat batteries going inside factories. One of the carbon-based batteries caused an evacuation of an industrial park all the way out to almost a kilometer. That's not acceptable for this industry. It's critical that we meet high safety standards. It is also critical that we have certainty of delivery. A lot of folks are going to be planning, they're not just choosing what is this heat battery versus that one. Am I going to be try to go down a carbon capture pathway or a biofuel pathway or something? We must know that there will be availability at scale, that they will be reliable. If a grid battery that's tied behind your meter doesn't work today, you're going to pay a little more for electricity. If a heat battery is not working, your factory may well be down. And heat batteries, heat is a bigger challenge than electricity because electricity can be transformed up and down. The consistent delivery of constant temperature, some heat batteries have solved that problem. Others have not, and we often get confused between storage temperature and delivery temperature. As I said, we found a technology that was already industrialized, and in fact was industrialized 200 years ago by the steel industry, storing heat at 1500 C to save coal combustion by preheating inlet air to the furnaces to 1200 C. Stacks of brick made from clay, from dirt. There is almost literally nothing cheaper. It's a stack of brick. It's not something that's in a pressure vessel or a tank. It's surrounded by lightweight insulation. There's 750,000 tons of this material in service right now at blast furnaces around the world. These units last many decades, being heated and cooled 24 times a day. Our contribution, why isn't everybody using this material? It's low thermal conductivity. And lots of folks have said, I need to use liquids or something that's high thermal conductivity to do the thing that a heat battery has to do, charge rapidly and then deliver heat continuously. We had a physics insight in how to use completely conventional electric heaters if we structured the brick structure properly, a kind of 3D checkerboard. We could use the physics of heat radiation to uniformly heat brick to essentially the same temperature as the electrical heaters. And we could use the same physics the steel industry has used for 200 years and the same physics that power 2/3 of industrial steam today to deliver thermocline superheated air from the brick stack, powering a completely conventional heat recovery steam generator. We make the same process conditions as the exhaust from gas turbines. Again, it's about 2/3 of industrial steam today comes from cogeneration. And as a side effect of the process that we developed, we also found a way to build in a technology called dynamic insulation so that Rondo Heat Batteries are actually the highest efficiency energy storage of any kind. 98% efficient, that is, 100 kilowatt hours of intermittent electricity delivers 98 kilowatt hours of continuous steam or continuous heat to a cement plant. We are today also building systems that do cogeneration with steam turbines. Half the world's electricity today comes from steam turbines. The highest efficiency way of making electricity is cogeneration, and cogeneration that delivers industrial steam at the pressure that it's used from cogens. We are in construction today at a cement manufacturing facility in Southeast Asia, and this is a technology that can deliver, just with the technology we have today, about 60% of the energy used in a cement plant, also at 98% efficiency. For a little more than a year now, we have been in operation a first 2 megawatt hour installation at a biofuel refinery in California, where we are part of their journey to zero. A lot of the biofuel in the world people are intending to put into an airplane wing and carefully measure its carbon intensity. Rondo Steam and Power at an ethanol refinery eliminates the refinery emissions, cuts the carbon intensity of that feedstock in half. This unit was originally our constructability test. It was also the technology validation and initial long-term performance testing of the storage media. This is each one of these bricks, as it happens, our marketing guys like to say, where are the Tesla Model X's? Each one of those bricks stores as much energy as a Model X. It weighs about 1,000 pounds. Each one of them is made in a continuous manufacturing process, a continuous firing process, at high yield with a manufacturing partner who is a winner of the Deming Prize for total manufacturing quality, with 2 gigawatt hours of production capacity now, rising to 90 over the next 3 years. We have ensured volume production capacity with a producer who's been producing refractory material for many decades. By design, there is nothing new here. We build projects as modules. We build individual boilers that are standardized so as to accomplish economies of scale from running a standard process and avoid learning lessons of custom designs at projects. And we are focused on ensuring that when our customers work with us, we have complete clarity about the full pathway from the electricity source to the molecule. Heat batteries are a blue ocean opportunity. We will be transforming, the world will be transforming many manufacturing processes. We have focused on making sure that there is freedom to operate for our customers and have secured important patents in driving the world's highest efficiency way of making hydrogen, aluminum, and ethylene, as well as a broad variety of other processes. We are today in agreements and in construction in a number of industries in 7 countries around the world, that those industries represent the great majority of the world's industrial energy use. And we have created a strategic investor advisory board focused on driving early deployment and focusing our R&D on meeting the needs of the cement industry, the chemicals industry, powering long-duration electricity production for AI, for producing fuels, for producing the critical minerals the world needs for electrification, as well as everything else, copper, aluminum, lithium, most notably, and one visionary energy efficiency and infrastructure investment fund. We build projects, we are meeting how the market wants to execute. We are fundamentally everywhere in the world, turnkey guaranteed delivery of heat battery installations and power islands, and structuring with finance partners and utility partners, storage as service and heat as a service projects. I'll mention a couple of those partners in a moment. We're building projects in 6 countries right now with a very large pipeline, both with our strategic investors and others. And a couple of the recent announcements. EDP announced a gigawatt hour of first projects with us. In that announcement event, their CEO, their commercial CEO, said, this is an opportunity to make our average C&I solar project 10 times larger and to enable us to offer our customers 80% decarbonization, not 20%. Aramco, the world's largest fuel producer, we announced last week, as it happens, an initiative to do a first gigawatt hour in the kingdom and to work on driving this technology into hydrogen production and carbon capture and desalination, as well as serving Aramco's opportunities. 2 weeks ago, we announced that we were in construction in Thailand for a first heat battery at a cement plant that will be in operation next year, and working with SCG Cleanergy, who are focused on the generational opportunity the world has today. The world's China plus one strategy. Industrials of all kinds are seeking to ensure 20% of their supply chain outside China, is causing a huge investment in industry in Philippines, Vietnam, Pakistan, India, Thailand, across the region, Indonesia. That industrial base is either going to be built on another wave of regret infrastructure powered by coal, or with just a little vision and just a little international finance at the same rate as elsewhere. We are at a tipping point where that industrial base is going to be on a clean energy infrastructure. And we could not be more excited. It is an amazing time, and I'm delighted to be speaking with you.
John, that's absolutely brilliant. We've got, I mean, it's a question actually more from my side, is, everyone's had been talking about, 2 megawatt hours, 20 megawatt hours, and then, we start to talk about 100 megawatt hours, and, the thing gets pretty big. We're shortcutting that whole process to talking multi-gigawatts, right? And so we're I think that we've got the solution to something that's desperately needed. And you've got the economics, as almost all the presenters today. But I think, given your experience in growing businesses previously, you go from sort of starving and being hungry to all of a sudden having more to do than you can do. So it's how do you deal with success? How do you deal with the scaling? And I think you were very clear about the production side. You can handle that, but it's also the customer interface, and you've got a lot of countries around the world, and you're morphing into being a big guy, right? And the teenage years are never easy. So I'm to use an analogy, right? But how do you transform? And I think the challenges that brings to an organization, not so much about the technology, but it's really the company itself in meeting that and making sure that, well, you really want to climb that hill as fast as you can, but you want to make sure that, all your customers are happy along the way.
Yeah, thank you. Yes, and that is, of course, the important matter. I mean, for all of what does the world need? Building big, new, clean energy infrastructure now, right? And that is not going to happen without a lot of different matters. As I mentioned, we're doing the most absolutely boring thing, using brick, not some material where it's going to take some years to prove, can we hit the safety and the other characteristics? Clear that away. Absolutely. Choose partners who are building big energy infrastructure now. Don't make rookie mistakes. Previously in my career, I've contracted very innovative solar technologies that did not get built. We also learned a lot of lessons in a 7 million man-hour project in the Middle East, and choosing the right partners for every part of that you just mentioned. That is, the partners who are developing the market, who are bringing their customer relationships, their finance and their development skills, and find the right structures to unlock the sales channels. We are today originating in many markets because we are educating those markets. But what we are finding is our partners, whom I just mentioned, are moving much faster with their customer relationships, because they see this class of technology creating, again, a generational opportunity. If you want to build wind and solar, everybody knows the grid is this huge problem that's slowing that down. We're talking about individual industrial facilities needing between 150 and 2,000 megawatts at a point where there's no grid connection needed. So, and projects that have a combination of, we can do it now, not 10 years from now, and it delivers interesting returns, and there is a customer on the other side who wants it. So, yeah, I mean, I'm sorry, the answer is a long answer. Part of it is also gray hair. I mean, there's a reason why my chief legal officer comes from Bechtel and ran operations around the world, that you need to build an organization that reflects the challenge that it's pursuing. Yes.
Yeah. No, and I think there's a very loud message there from you and from all the others that the financial community has got something in front of it that it really needs to get its head around. I mean, today we've had a ton of financial players join this call, because I think they're starting to recognize that part of this is also really providing the capital, not just for the corporate growth, but also for putting projects in the ground, right? And it's a big, big opportunity. So thank
Yes,
you for
and
that.
that second matter that you mentioned is, of course, one of the biggest matters.
Mm.
If we're going to industrialize, that means we've got to have a clear pipeline of projects that are permitted and have capital. The so-called first of a kind large project capital
Yeah,
is really critical. You know, a month ago, the Department of Energy awarded 33 projects that were specifically designed to get new technologies to large scale.
yeah,
Two of those are Rondo projects. We're proud to be working in a couple of industries and moving along that journey. You know, there'll be a capital raise later this year to power the building of the team to deliver on these opportunities. And at the same time, we are exploring project finance partners and
yeah,
partnerships, and we're keenly interested in folks who want to be in these, you know, the first 10 gigawatts are maybe the hardest, right?
yeah,
As we
yeah,
build out the track record, we move to, you know, from the beginning, we've been focused on being boring, but, you know, once we get a few gigawatts in the ground, we will be more boring and be conventional, because that is
right.
the sprint to how fast do we make this conventional. There
Yeah,
are challenges contractually because in many cases, we're building a large facility that serves a single customer rather than the grid.
yeah,
So there are creditworthiness and second life use and all sorts
yeah,
of other
yeah,
matters. But bringing the technology to the scale that it's conventional does require large capital, right?
yeah. And we
What
think,
Dave Danielson at Breakthrough likes to say, no gigatons without gigabucks. And he's right,
well,
that's true across all
he's so right.
technologies.
But
Yeah.
and also listening about the economics and the potential of negative energy prices and so on. You know, there's some really interesting stuff for the financial community to get their head around. Some very
Yeah,
interesting
yes, indeed.
projects.
In fact,
Absolutely.
Jesse Jenkins wrote a study that just published last month that pointed out that heat batteries in electricity grids make renewables more profitable in the
Yeah.
areas where they are, such that the grid-wide carbon savings elsewhere in the grid are as large as the carbon savings at the heat battery deployment point. And that means also that the people building utility scale renewables benefit from this, and connecting those dots is a challenge. And I'm grateful that you're working on this webinar to educate
Yeah. No, absolutely.
players in all different parts of the energy system.
There's been a lot to absorb. So thank you for that, John. That's absolutely brilliant.